And there we go, we're rolling. And we are going to our notes. And there we are. Today's lesson is the cosine law. And okay, let's pretend, don't look at the bottom of the page. Can everybody go to this L3 page, lesson 3, cosine law? And let's say that I wanted to solve for, let's see, what am I going to solve for? Let's solve for angle A in this triangle. Okay, so let's try it. So here's angle A down here in the corner, right? So this is what I'm trying to solve for right here. All right, so I guess we should label the other sides. If that's angle A, this is side A. If this is angle B down here, this is side B over here. And they label side C for us. That's very nice. Okay, let's see if we can find angle A. So, well, the formula for sine law is sine A over A equals sine B over B equals sine C over C, right? That's the formula. Okay, now in the next step, now we can scroll down a bit. Put all the numbers in here that you know. So they did it for you. You don't have to write it down. We know, oh, and they actually did it, sorry. Oh, I see them. They're not looking for, sorry, I misread this. They're looking for side C. Actually, it doesn't really matter. As you're about to find out, we can't figure out either of them. But they're looking for side C. So, okay, so instead of angles on top, let's put the sides on top. A over the sine of A equals B over the sine of B equals C over the sine of C. Okay, so there we go. So what we want to solve for is we want to solve for that one. There we go. Guess I should have read the question before I started talking about it. All right. Plug in what we know. Well, we know side A. There it is. Side A is, let me use a different color, yellow. Side A is 17, so they put it there. We know side B. Side B is 32. They put it there. And we know angle C is 105. So if the thing I'm looking for, let's go back to green. If the thing I'm looking for is this side C, which of the two ratios here should I be using? And do you see the problem? I can't use either of them. Why not? Because I don't know both parts. I know the side, but I don't know the angle. I know the side, but I don't know the angle. And it's like, okay, well, we've had this problem sort of before. And then you know how we got around it, right? We used the 180 rule. As long as we know two of the angles, we can add and then subtract from 180, and we know the third angle. Problem, I only know one angle. So actually, what we've figured out here, hopefully, what I hope that we've figured out by looking at it, is that we're stuck. The sine law can't solve this problem. So that's why we needed another law. We need the cosine rule. So in example 1, given two sides and an included angle, for the triangle above, notice that we are given two sides and the size of the angle formed by these two sides. Let me just scroll back and show you what that means. What we mean is, we are given, I'll use the green highlighter again, we are given this angle and we're given the two sides that make that angle. In mathematics, we sometimes call this a side, angle side problem. In other words, the angle that I know is between the two sides that I know. And if that's the only three pieces of information they give me about a triangle, sine law won't solve it. That's why I need cosine law. Cosine law, let's finish filling the blanks here. This angle is known as the, what's the word that I want here? Oh, the inscribed angle, meaning that it's found between the two given sides. And we can use the cosine law to solve for side C in this triangle. First, let's look at the cosine law. Okay, the cosine law, as you can see, is a much more complicated formula than sine law. And sine law only has kind of two ways to look at the formula. I can look at it where the, look back to the notes here, I can look at it where the angles are on top, or I can look at it where the sides are on top. Check out cosine law. Just in today's lesson, there is 1, 2, 3 ways to organize the formula. Tomorrow's lesson, we'll see 3 other ways we can organize the formula. But notice they all kind of have something in common. If this was a pre-calc class, in pre-calculus we expect you to understand where these formulas come from, and we derive them. But I bet just by looking at it, you could probably guess what other formula helps you get the cosine law formula. Does this part here look kind of familiar? What does that remind you of? It's Pythagoras. The cosine law formula comes from taking a triangle that doesn't have a right angle and then drawing a line in it to make it into two right triangles, and then using cosine and Pythagoras. And when you do that, you end up with these three formulas. Now, I am looking in this picture for for side C. So I am going to use the C version of this formula. So it says in the notes next, go to the next page, technically the cosine law is just one of the above three formulas. But once again, see a pattern to it? If I'm looking for side A, then B and C are on the other side, and B and C go here, but it's the cosine of angle A, the angle opposite to the side I'm looking for. If I wanted B, notice it's A and C, the other two sides, and then here they are again, the other two sides, but the B is the same as, or is the opposite side to the side I'm looking for. I should say the opposite angle to the side I'm looking for. Here's the one I'm going to use today for this example. Side C, notice again, angle C is across from it, so C goes in this part of the formula. And then this is A, and this is B, this is A, and this is B. And you have a little bit of room here. The reason why it's important to understand this sort of pattern in the formula is because not every triangle that we'll give you will be lettered with A, B, and C. Like say, for example, I gave you a triangle that was corner X, corner Y, and corner Z, which would make this little side X, this little side Y, and this little side Z. Draw that out. And what if I needed the formula for cosine law to find side Y? Can you see the pattern in these formulas here and tell me what this should be? I'll give you a minute to think about it. Try writing it in pencil. The worst you can be is wrong and then have to erase it. So give it a try. What do you think that angle, or sorry, the rest of that formula should be? It has to look like these formulas. So what will it look like? I have to, this is an important skill because here, let me get rid of all these extra things here. Because, again, we don't have a provincial exam, but I'm not going to do things that differently in the course. I'm not going to change the way I teach this course just because we're not having a provincial exam. If there was a provincial exam, though, I'm going to tell you right now, they never give you all three of these formulas. On the formula sheet for the exam, they just give you this one. They figure that you understand the pattern well enough to rearrange the formula any way you want. So that's why we're doing this right now. What if it wasn't A, B, and C? It'd be y squared equals the other two sides squared minus 2 times the other two sides times the cosine of the angle across from the side I'm looking for. See how that formula works? Now, this is going to sound like, old man talk. Old man saying how hard his life was and how easy yours is. No. This old man gets it. Actually, your generation has it far harder than mine. I didn't have to go through high school through a pandemic. Political discourse in the media in my era was far more civil and real, and our neighbors to the south did not have people attacking their seat of government, and there was just many things in society far easier when I was your age than they are now. I had it good. But one thing they used to make us do that they never make you guys do is memorize formulas. We didn't get formula sheets in high school math. We had to memorize them. So what I'm doing right now, being able to figure out the formula for myself, was key to survival. For you guys, all you have to do is be able to come up with the formula you need right now. You'll always get this one, though. So let's see if we can get the formula we want. Don't peek. Flip the page, and let's see if we can get the formula for C. So if I know that the formula is a squared equals b squared plus c squared minus 2bc cosine of a, if that's the one they give me on the formula sheet, what does the formula look like for C? Without peeking, see if you can get it. And again, it's actually c squared. And actually my pen just stopped working. There we go. See if you can fill that out. Without peeking back. Don't peek at the page before. No cheating. Again, we used to have to memorize formulas. And those of you who are double dipping, who've been in the pre-calc course, think of all those combinatorial formulas. Yep, we had to know them all. Ooh, the trig identity formulas. Remember those? Yeah, they made us memorize all that stuff. You know those? Quick, what's sine alpha plus beta? Yeah, remember that one? Okay. Isn't it sine A times cos B plus cos A times sine B? Isn't that it? And the only reason I have that memorized is because, again, my grade 12 teacher made me. Okay, so here we go. Actually, we did that in grade 11 back in my day. All the trig was in 11, and all the other stuff was in, all the logarithms and stuff was in 12. And the graphing. You guys started doing graphing in grade 11, like quadratic graphing and stuff. When I took it, all the graphing was in 12. We didn't do any graphs. Grade 11 was all about trig and algebra. And then all the graphing and logs and stuff was in grade 12. So it was different in those days. Okay, anyway, did you get that you put a squared plus b squared minus 2ab, and then you times that by the cosine of angle C? Remember, in algebra, when you put letters, variables next to each other, and you don't put a symbol between them, that means times, right? Don't write this down, but that means 2 times the x number times the y number, right? So same logic here. This is the number 2, the number 2 times the number a times the number b times the cosine of C. That's one number. Remember, cosine's not a thing, right? It's an operation. But I'm doing that operation and I'm timesing. This is where, boy, we're really going to give our scientific calculators a workout. Let's put in the numbers now and figure out what we're doing. So c squared is equal to, okay, oh, we have to relabel this diagram. Which one's a again? A is the 17. Which one's b again? B is the 32. Minus 2. Now, I don't like to use x's for multiplies, so I have two options. What are the other things you can use for a multiply symbol? You can use a dot. I tend to use a bracket. It just keeps my work nice and neat and easy to read. Does that mean I have to punch in a bracket when I'm punching buttons on my calculator? No, please don't. Only use brackets when you have to, when you're punching buttons on a calculator. And then times the cosine of, what's angle C again? 105. Okay. I have no interest whatsoever in what this number is, and this number is. Don't bother. You've got yourself a scientific calculator. You paid good money for it. Let's use it to its capacity. Let's actually force it to do some bed maths. I lived down the street when I was a kid from a doctor who was retired. He was an older guy. He probably worked till he was 70-something. So he was in his mid-70s. And of course, he's retired and he has lots of money. He used to be a doctor. So he goes out and buys himself like a really nice sports car, like a Porsche. But the guy's in his mid-70s. So you know how he drives it? Driving down the street in this, you know, in those days, $40,000, which nowadays is probably an $80,000 car. That's what you guys are like with your scientific calculators. You have this high precision machine in your hands, and all you want to do is just punch plus, minus, times, divide. This thing's a race car, man. You got to take this thing out for a ride once in a while. 17 squared plus 32 squared minus 2 times 17 times 32 times the cosine of 105, and then hit equals. I get this number. I'm going to repunch it to make sure I've got the number right. Sometimes I punch the buttons twice just to make sure I did it right. I think I did it right. Yep, I got the same number twice. This must be it. Punch buttons, is that what you got? I want everybody to punch buttons. Kevin, I want you to punch buttons. Everybody, give this a try. Make sure that it's making sense to you. Do it as one big calculation. There is kind of a reason why I say that too. Do it as one big calculation. It's not just because I think your calculator is a race car and I want you to drive it fast. It is also because you're probably less likely to make mistakes. Students who approach this by going, okay, I'll times 17 squared in my calculator, then I'll write it down. I'll times this squared and I'll write it down. I'll times those things together, write it down. Then I'll times this and write it down. Then on the next step, I'll times those two things together and write it down. You know, every time you do that, write it down, guess what you're very likely to do? Accidentally write the wrong number, or accidentally punch it in the calculator on the next line using the wrong number. You're far more likely to make mistakes that way than just typing it all as one big calculation. There's people shaking their heads going, no, I'm not that good at punching buttons. I'm probably going to goof that up. Not if you practice it. Trust me. Come on, you are the generation of button punchers, right? And you all, and I see you guys, this is how you type your calculator. That's not me. See, my generation punches buttons like this. You guys are. You're good at it, though. Okay, so I'm going to get all this green stuff out of the way. Is there anybody who tried punching and didn't get this number? If anybody's using one of these calculators where, again, you have to have the number on the screen first, it should still work. Okay, person at home who's asking me the question, try punching it like this. Try going 17, then hit the squared button, plus 32, then hit the squared button, minus 2 times 17 times 32 times, and then you have to hit 105, hit the cosine button. Now, the screen just changed for me. It says negative 0.2 something, but that's because I haven't hit equals yet. So give that a try. If it's still not working for you, after I'm done this example in this lesson here, I can put on the document cam and we can punch buttons together, all right? All right, so, gee, C is the longest side, but does it really look like it's long enough to be 1,594 centimeters long when this guy's only 32 and this guy's only 17? I kind of think maybe that's not the right number. Oh yeah, I got one more step. What's my last step? Square root. I don't want to know what C is, or C squared is. I want to know what C is. So I got to square root this 1,594 blah, blah, blah number. So I am going to square root. Now again, on this calculator, if I just hit square root, the number on my screen right now goes away. How do I get it back? Use the answer button. So square root answer equals. And okay, does it say where to round? I don't know, I gotta go back to the original question. No, it just says solve. So it does not tell us where to round, so I'm gonna just round it to my two places. So 39.93. Oh, I stopped there and lost half a mark. What'd I forget? Centimeters. It was centimeters, wasn't it? Yep, centimeters. If the question has units, the answer has units. Right? Okay. Let's do another one. Oh, that's right. I got to make up the next one. Okay, so I'm going to make this one up. So in your booklet there, let's go example 2. And this time, let's for sure not use A, B, and C. Let's force us to do the formula. Let's make up an example that is, let's say, let's make a really skinny angle over here. Like this will be, say, 31 degrees. And this longer line will be 15 centimeters long. And this shorter line will be, oh, I don't know, 9 centimeters long. And I'm going to call this angle X, and this angle Y, and this angle Z. And I would like to find the length, and I'm going to misspell length. I'm going to start the word length with an N. Yeesh. Find the length of YZ. Okay, so that's a very good kind of test type question that you might get. It's got all kinds of complications to it. Now, you guys have an advantage right now because you know it's a cosine law question. On the exam, you wouldn't know that. The exam doesn't break the trig section into, oh, here's the sine law questions and here's the cosine law questions. Knock yourself out. No, it expects you to know what to use and when. So what about this question tells me it's not a sine law question? Because as it said in the notes a minute ago, the angle that I'm given is between the two sides that I'm given. That's the key. That's why I know it's a cosine law question. So I know it's cosine law, so I might as well write that down. There's my cosine law. I wouldn't bother writing this down if I was writing the exam because I have the formula sheet right in front of me. So I'd go look at this number, go look at this formula on the formula sheet. There it is. Now I have to apply that formula to this situation. How do I do it? Well, calling the side xy, or sorry, calling the side yz, that's what I meant to say, that doesn't really help me much. Where is that side? Well, let's see. It's the side in yellow from here to here, right? It's this guy right here in yellow. That's what I'm looking for. That's that side. What should I call that side to keep my formula working? Is it little x, little y, or little z? It's little x, because it's across from x. So there's the first step. Label the other sides so that I'm using lowercase letters like the formula does. Now, if I'm looking for yz, which is again x, what does this formula look like if x squared leads it instead of a squared? So I'll give you a sec to try it. Again, if you're using a pencil, you can just erase it if you don't have it right. You got to try. Don't just wait for me to give it to you. Come on, give it a try. What do you think the formula is? All right, did you get that if it's x here, it has to be y and z here minus 2yz's times the cosine of angle x. That last part should totally make sense because notice it's the only angle we gave you. Was angle x. Kind of makes sense. That has to be the one in the formula, right? All right, now let's plug in the numbers. Y is 15 and z is 9. And notice if you'd have mixed up which one's y and z, you'd have still got the right answer. Because you can add and multiply things in any order you like, it wouldn't change it. But if you had more than one angle that was in this question that you knew and you put the wrong angle where the 31 should be, then you'd get the wrong answer. Of course, if you had more than one angle, you wouldn't be doing cosine law, you'd be doing sine law. But anyway, now it's time to punch buttons again. All right. Give this a try. And again, if this isn't working for the person at home who has their hand up, I will I will turn on the camera after this example, after I've turned off the video and stuff, and I can show you how to punch buttons. Okay, so 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine of 31. I get that x squared is 74.56 blah, 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 blah. But that's not what x is. Square root my answer, and I get 8.64 centimeters. And there it is. Okay, so that's part one of how we use cosine law to find missing sides, given side angle side. Part two we'll do in our lesson on, I guess, Monday. So I'm going to just stop my video for now. We'll do a part 2 video on Monday. Thanks for watching.